Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies. In this latest ChassisSim video tutorial, what I'd like to talk to you about is how to go about dealing with the situation when features such as the Tyre force estimation and the one-touch aero modeling don't quite go to plan. Now, before I get into the tips and tricks about how to do this, I really want to sort of provide you all with sort of a bit of a background to what the Tyre force estimation and the one-touch error modeling is, and their role in using ChassisSim. Their primary role, just to refresh everyone's memory, the Tyre force estimation takes in a monster file. And what it does is it looks at lateral data, takes a static approximation to come up with a rough approximation of the traction circle radius versus load characteristic. The one-touch error modeling takes a single monster file, and what it does is it uses that that single run of data to come up with an approximation of your downforce levels and what the aero map looks like. I want to state something here from the get-go. These are tools to get started. Now, in a lot of cases, they'll get you about 80. They'll get you between about 70, 80% there. But they are there to give you a start. However, if they don't go to plan, if things don't quite go to plan, believe it or not, actually dealing with that is really, really easy. Let me talk to you about the first example to deal with, and that is when the Tyre force estimation doesn't quite deliver the result that you're after. Vis-a-vis, you'd be looking at a result. This is actual data, and this is actual data, and this is an example of when the Tyre force estimation hasn't gone to plan. Now, most people would look at that in particular, would look at the speed trace and go, oh my lord, this is a complete disaster, we've got to start again. Believe it or not, there's a really simple fix for that. The fix for that is that once you've loaded up your Tyre force estimation, all you need to do is click on the front tyres and basically increase the global grip factor. So, as a rough rule of thumb, what I would do is increase it by 20%, and just to make it just a little bit more obvious what we'd be actually looking at, is I'd increase that 0.9 to 1.1, and I would increase that rear grip factor from 1 to 1.2. And to show you the effect that can have, this is basically when I've gone through and changed that grip factor by 20%. See how that looks so much better? And yet, that's a really, really simple tweak that you can that you can accomplish. Remember, our goal in using the Tyre force estimation is not necessarily to come up with the perfect tire model. Our goal is to get going, and as I have spoken on many other occasions, the trick with simulation is you are going to be a hell of a lot better off in actually getting going with some numbers first, so you can get a feel for what's what and what isn't. The next point I'd like to talk to you about is what do you do when the one-touch error modeling doesn't quite go to plan? Well, an example of that is right here. As you can see, our coloured trace is actual, our black trace is simulated. And as you can see, coming down the main straight, we're way too fast, and we don't have enough front downforce. Now, most people would look at that and go, "Oh my lord, it's terrible. It hasn't worked." Well, there are two ways that you can actually solve this problem. The first is that you actually have a look at the data and you take a look at basically where the bulk of the straight data is coming from. And as we can see, we've got G-force lat at about 0.16 of a G, and as we can see, just zooming in on this particular straight, we've still got a little bit of built-up lateral G in that situation. Now, if you've got a situation like that, a really simple fix is if you go into aero modeling and you go into your advanced settings, you can see here that these are basically your bypass settings for which the the aero toolbox is going to be taking its numbers. So what we did on this particular occasion was to go through and basically raise the bound so we can encompass more data for the the one-touch arrow. And in the version 3.2.1 release, this dialog will actually be in the one-touch arrow modeling. And to give you an example of the effect that had is that, let me just show you the wideband the wideband results. What we'll do here is, here's our actual data. Here's our wideband results, and as you can see, automatically the results have become a hell of a lot better, particularly through here, and the drag results have gone down, a bit. They need a little bit of work. We're going to touch upon that in just a moment. And as you can see through here, we've probably still got a little bit more rear downforce than what we would like, but going down the main straight here, we're actually pretty good. Just a quick note on all this. This comes from a circuit where you've got significant altitude road camber variations so sometimes you're going to have to do a little bit of tweaking before you can do a proper aero test program. But as I said before, the one-touch arrow is designed to get you going, and don't ever forget that. Now, in a situation like this, if I've got a little bit too much drag and I need to tweak my downforce and aero balance, all I do is I click on the rear wing and I start playing with my CLA, CDA max, and aero balance offset. Let me just go through these settings very, very quickly. The CLA max is the maximum possible downforce you're going to get from the aero map. The CDA is the maximum CDA you're going to get from the drag map, and the aero balance offset basically offsets the aero balance by percentage divided by 100. So in this case, we've got an aero balance of 0.01, which means that the aero balance is shifted plus 1% from the downforce. So in a situation like this, where I'm running a bit too much speed, what I would do is I'd change that CDA from say 0.85 to say 0.95. And what I would do with the aero balance offset, I'd probably take that back by about minus 0.03. So I'd shift it about 3% back. And what I would do is I would go through, I'd run after I've created my curvature and my bump profile, I would go through and I'd run simulations, compare it between actual and simulated data, and then basically get myself into the ballpark. And this only really should take you about 3 or 4 runs. Some rough rules of thumb: if you've got a situation where the front dampers are significantly shifted forward and the rear dampers are significantly shifted back, that's when you go through and you play with aero balance offset. If you've got a situation, obviously, where the simulated damper traces are just too optimistic, that's when you drop total downforce and total downforce. And if you're generating too much speed, you drop the drag. But this just shows you just how simple and straightforward it is to go through and tweak those results. So if things don't go to plan, don't panic. And really, what I'd like to do is I'd like to leave you with this thought. The thing about ChassisSim is that ChassisSim's a very, very powerful piece of software. But at the end of the day, it's a calculator. And really, as someone who has worked in the field of race car engineering, data engineering, vehicle dynamics for over 17, 18 years, just remember, these are tools, these are calculators. Use them as such. Don't expect just to if you have a problem, just to plug in numbers, hit a magic button, and it gets solved for you. Remember, these are tools, and this applies for any numerical based software you're going to be using, whether it be MATLAB, SolidWorks, ChassisSim, any finite element analysis package that you'll choose. Just remember, The results are only going to be as good as the data you're going to be putting into as the data you put into it, and the sort of bits and pieces that you've got to do, and the adjustments that you need to do to make it match up with what goes on with the real world. If you do that, this will be a really, really powerful tool. But look, don't take my word for it. Give this for existing ChassisSim users. Give this a run. If you're not if you're not a ChassisSim user yet, by all means sign up for the professional online simulation and play with this yourself and see what a powerful tool ChassisSim can be.